Let's look at the domain and range of compositions of functions. The domain is going to be considered all of the original inputs of a function that eventually will produce an output of that function. So if you put it into the function, eventually you'll get something out. It won't lead to doing something undefined. And then the range is the final outputs of that function. So to do this, and we're talking about the real numbers for these functions. To do this, I want to break down the layers of my function. So here I have a function cosecant 2 cos inverse of x over 4. So I start with my x's, and with those x's, I'm going to take all those values and divide them by 4. Next, with all those values divided by 4, I'm going to input those values into the arc cosine function. So I'm going to take arc cosine of all those x values divided by 4. Next, I will take whatever arc cosine of all those x values divided by 4 is, and I will multiply them times 2. Finally, I will take cosecant of that result, leading me to my eventual outputs, or my y values here. So I break down the layers of this function, and then we're going to look at the function at each layer and decide if there's any special considerations that we should make. So we're going to start with all real numbers for x, and we're going to take all real numbers and we're going to divide them by 4. So we're still going to have all real numbers, but compared to the ones we started with, they're going to be divided by 4, which is important to kind of make note of. Then we're going to take cos inverse of all those real numbers divided by 4. But cos inverse only accepts certain numbers. And at each stage, it can be helpful to sketch a little graph of the current function to remind yourself of what that function will actually accept. And so the cos inverse function only accepts inputs from -1 to 1, and it'll output things from pi to 0. Comparatively, on the unit circle, that comes from the quadrant 1 and quadrant 2. So the cos inverse function actually only will take inputs from -1 to 1. So from my real numbers over 4, the things that will actually give me -1 to 1 would be starting with anything from -4 to 4. So my original x's actually should have only been -4 to 4. When we divide -4 to 4 by 4, we will get -1 to 1, which is what cos inverse can accept. And so each time we encounter something that is leading to us doing things that are undefined or not part of the domain, we go back up the chain of the function and restrict to only the things that would actually work. Now we take cos inverse of -1 to 1. We're going to get everything out from 0 to pi. We can see that looking at our graphs to the right. Next, we are going to multiply all of those outputs by 2. So 2 times 0 gives us 0, 2 times pi is 2 pi. So that'll give us out everything from 0 to 2 pi. Finally, we're going to take cosecant of everything from 0 to 2 pi. So it can be helpful to sketch a little graph of cosecant to remind ourselves of what that might do. Cosecant is the reciprocal of sine, so I'm just going to sketch a little sine curve, and the actual cosecant function itself, being the reciprocal, ends up looking something like this. But we are only actually interested in the window from 0 to 2 pi. So this is the window that we're actually inputting into the cosecant function. And we will get out everything from, here's 1, here's -1. And so we'll get out everything from -infinity to -1. Oop, that's inclusive. And we will also get everything out from 1 to infinity when we take cosecant of those values. There is a consideration, however, because cosecant has asymptotes. And so these 3 asymptotes in particular, 0, pi, and 2 pi, do not produce an output. So when I put in 0 pi or 2 pi to the cosecant function, I actually don't get anything out. So those are not elements of our domain because they don't eventually produce an output. Now we have to work back up the chain to figure out where 0 and 2 pi came from. So we said 0, we also said pi, and 2 pi do not work, right? So we have to go back up the chain to see where exactly did those things come from. 0, pi, 2 pi. Well, we had multiplied 0 to pi by 2, so 0 gave us 0, pi gave us 2 pi, and then pi over 2 would have given us pi. So 0, pi over 2, and pi were the ones that led to those issues. Those came from the cos inverse function. 0, cos inverse of 1 is 0. Cos inverse of -1 is pi, and cos inverse of 0 is pi over 2. So -1, 0, and 1 were our problem numbers from before. Then we remember that before we got those numbers, we had divided by 4. So the numbers that actually resulted in -1, 0, and 1 were -4, 0, and 4. So that's where our original problem started. So instead of -4 to 4, we should actually have -4 to 0, and then 0 to 4. So all the numbers except -4, 0, and 4. And to see why, let's retrace one of those numbers back down this path to see why it's a problem. Say we had chosen 4 for our x value. We plug in 4 and we divide it by -4. That leads us to, let's pick a good color here. Let's do blue. Let's take 4 divided by -4. That led us to 1 down this chain. Then 1 we plug into the arc cosine function. And when we plug in 1 to this arc cosine function, our cosine of 1 gave us 0. Then we multiply that by 2. 2 times 0 is simply 0. And then finally we take cosecant of 0. But when we go and we look at our graph of cosecant, we can't take cosecant of 0. There's an asymptote there that's undefined. It's the same thing as 1 over sine 0. So this whole line from 4 down the whole chain all the way to cosecant actually does not produce an output. And so that is why we took it away from this original part of our domain. So as you go down the chain, as you find things that break, you have to remove it from your original set of inputs here, because the domain is the original inputs that eventually produce an output. And so to put it all together, the domain of this function is going to be -4 to 0 and 0 to 4, nothing inclusive. And the range of this function is -infinity to -1 and 1 to infinity. And what you can do is sketch these functions on Desmos to sort of confirm this fact. So I have them preloaded. And if we look on Desmos at this first function, we can see our domain is everything from -4 to 4, but we don't have inclusion at -4, we don't have inclusion at 4, and we don't have 0. Those three parts of our function are undefined, but everything between them was good. Then if we click here, we get -1, and then we go down towards infinity, and we also get +1 and go up towards infinity for parts of our range. So we were correctly able to reason about the domain and range of this function by going through that process. So what I'm going to do is 2 more examples of thinking this out. So in our second example, we have the square root of sine inverse of x minus 5 over 2 pi. So we start and we model our function. We start with x's. From those x's, we are going to subtract 5. Whatever the result of that is, we're going to take sine inverse of that. Then we are going to take whatever sine inverse of that puts out, and we are going to divide it by 2 pi. And finally, we're going to take whatever all that divided by 2 pi is, and we are going to take the square root of it. And that will produce our final outputs, our y values. And so let's go through this process. For starters, we begin with all real numbers. We can choose any real number for x. And we're going to take all those real numbers and we'll subtract 5. So we'll still end up with all real numbers. They'll just be shifted by 5. Then we go to take sine inverse of all real numbers minus 5. Let's make a quick sketch of sine inverse to help us think about what's part of that and what's not part of that. Sine inverse looks a little something like this, with positive 1, negative 1, pi over 2, and negative pi over 2. You can also compare it to the unit circle, quadrants 1 and quadrants 4. And what we realize is that we can't actually accept all real numbers into sine inverse. We can only accept numbers from negative 1 to 1. So this has got to go. And so we only want negative 1 to 1. But now we have to go backwards up the chain because we subtracted 5 from numbers. What minus 5 is negative 1? Well, that would be 4. And what minus 5 is positive 1? Well, that would be 6. And so to get that negative 1 to 1, or to get, in this notation, negative 1 to 1, the x values we could start with are not all real numbers. They're, in fact, only the numbers from 4 to 6. 4 minus 5 would be negative 1, 6 minus 5 is 1, and everything in between. Okay, so we've limited our domain already. Now we take sine inverse of all those things, and looking at our graphs, sine inverse will produce negative pi over 2 to pi over 2. So we have negative pi over 2 to pi over 2 is the next layer of our function, and that is inclusive. Then we're going to divide those values by 2 pi. And so what we'll end up doing here is if we look at like pi over 2 divided by 2 pi, that's like 1 multiplied by 1 over 2 pi, we're going to get 1/4. And if we do negative pi over 2 and divide by 2 pi, we're going to get negative 1/4. So dividing all those values by 2 pi is going to give us everything from negative 1/4 to positive 1/4. And then we're going to put that into the square root function. And square root, if we sketch its graph, looks a little something like this. And so square root does not accept negative inputs. So this is no good. We can only actually accept numbers from 0 to 1/4. And the square root of 0 is 0, so that's okay. Going back up the chain, figuring out where did those negative values come from? Well, the negatives came from everything negative a step before it, so we have to take out negative pi over 2 to 0, and we can only take 0 to pi over 2. Going back up the chain, we want arc sine, and we only want it to be 0 to pi over 2, so we only want this part of the arc sine function, so we actually only wanted 0 to 1. Going back up the chain, 4 would have given us negative 1. If we want our cutoff to be 0 and we're subtracting 5, we should really only be using 5. So 5 minus 5 is 0, 6 minus 5 is 1. And then we have to get rid of this 4, and in fact we have to say our original domain that would work is only 5, 6. And now we've covered every layer of our function. We take the square root of 0, which is just 0, so our y's can be 0. Square root of 1/4, what times itself is a fourth? Well, a half times a half is a fourth, and so our other endpoint is 1/2. And so our eventual y value outputs are going to be from 0 to 1/2. We've accounted for all the problems. We've gone back up the chain a few times and restricted. So our final answer is that our domain is from 5 to 6, and our range is from 0 to 1/2, inclusive. And so this process should have worked. Let's check on Desmos if we sketch a graph of this function. And there it is. we see that our domain is from 5 to 6, inclusive, and our range is, if I could click it, well, highlight over it, 6 to 0.5. And so, our range is 0 for our y value, and then 0.5 for our maximum y value. So we are correct. We were able to reason through this, and this function eventually produces this funny little piece of a curve here. All right, let's do one more example. So this function is going to be tan of arc cos of log base 2 of x. So we have three types of functions, all composed together. We start with our x values. All those x values we choose, we're going to take log base 2 of them. Then we are going to take the inverse cosine of whatever log base 2 of our x values is, or are. And finally, whatever cos inverse of all that is, we are going to take the tangent of that. And finally, we will get our final outputs, our y values. So our x's, we're going to start with all real numbers. Some of them might work, some of them might not, but that's where we start. Our log function, log base 2, we're going to sketch a little curve. Log functions have a vertical asymptote, or the parent ones do, at x equals 0, and they only accept positive inputs, and they give out all real numbers. And so if I try to put all real numbers into the log function, that doesn't work. I can only actually put in positive values. So 0 to infinity, and 0 is not included. We cannot take log of 0. So this all real numbers we started with, nope, we can only actually put in positive numbers. Next, we're going to take cos inverse of log base 2 of 0 to infinity. Well, log base 2 of 0 to infinity outputs all real numbers. We get all the negative numbers over here. We also get all the positive numbers, and they go on and grow forever. But if we sketch cos inverse, we don't actually accept all those real number inputs. Cos inverse looks like this. Our inputs of cos inverse, it'll only accept -1 to +1. And again, it's really good to connect this to the piece of the unit circle, quadrant 1 and quadrant 2. And so we don't want all real numbers into cos inverse. We only want everything from -1 to +1 inclusive. So we've got to go back up our chain and say log base 2 of what is 1, and log base 2 of what is -1. First part's easier. Log base 2 of 0, or excuse me, log base 2 of 2, you can't take 0 as an input, is equal to 1. So we can say our cutoff on the top end here is actually 2. Log base 2 of 2 will turn into that 1. Then we want to think about log base 2 of what equals -1. And so that is log base 2 of 1/2. 2 to the power of -1 is 1/2. And so our other cutoff point here is -1/2. So those are the things that we actually want to be taking the log of. And so our x gets restricted. Our original inputs can only be -1/2 to 2. Because we'll take the log of those things, and those will produce -1 to 1 going into the cos inverse function. Now we take cos inverse of -1 to 1, and the outputs of cos inverse, we can see are pi and 0 and everything between them. So we get 0 to pi, inclusive. And finally, we're going to take tangent of 0 to pi. So let's sketch a little graph of tangent to think about what that might be. Tangent starts at 0, 0, goes up, goes down, has asymptotes, and repeats itself forever. And let's do a little sketch here. And those asymptotes are when cosine 0, because that would be dividing by 0. So we have asymptotes at pi over 2, asymptotes at pi, not pi, 3 pi over 2, my mistake, and so on and so forth. Now, we're only taking tangent of everything from 0 to pi. So we only need to look at the tangent graph from 0 to pi, which is this slice of the tangent graph right here. And if we look at it, we see we actually get out everything from 0 up to infinity, and from negative infinity back to 0. So we'll get everything from 0 to infinity, 0 to negative infinity, and we will get out all real numbers. So our final set of outputs is everything, all real numbers. Importantly, though, we don't get anything out when we plug in pi over 2. So pi over 2 doesn't actually give us an output. So we shouldn't have pi over 2 here. No pi over 2. And so this, we're going to actually say we only want tangent of 0 to pi over 2, and then pi over 2 to pi, but we don't include that pi over 2. So now we have to work our way back up the chain. Cosine of what led us to pi over 2? Well, cosine of 0, or sorry, arc cosine of what? And arc cosine of 0 was pi over 2. So we have to take out 0. So we're going to say -1 to 0 and 0 to 1. So this, we should have no 0. Okay. And we took the log of stuff, and that log produced numbers, but we can't take 0 from the log. So our question to ourselves is like, well, what log of what is 0? Log base 2 of what is 0? 2 to the 0 is equal to what? 2 to the 0 is 1. Log base 2 of 1 is 0. And so at this stage of the chain, we're going to say, nope, we actually were from -1/2 to 1. Couldn't do 1 because that would have given us 0, and 1, 2. And then that is our original x values that work. -1/2, 1, and 1, 2. Okay, and that's good. And so then our final domain is that -1/2, 1, and 1, 2. And our final range is all real numbers. And just to illustrate why we had to take that out, suppose we had plugged in 1, so x is 1. We plug that into the log function. Log base 2 of 1 is 0, so we would have gotten this 0. Plug 0 into arc cosine, we will get pi over 2. And then if we try to take tangent of pi over 2, well, that doesn't exist. It's undefined. So that's why we have to take this 1 out of this original x inputs, our domain, because it would never have given us an output at the end, or it can't give us an output that's defined. So that's the logic behind when we take these things out, back up the chain. So if you think about it, think like you can visualize putting it back and seeing what would have happened if it was part of the domain and why it doesn't actually result in an output. And finally, let's just take a peek at that graph. Tan arc cosine of log base 2 of x, and here it is. If we zoom in a little bit, we have everything -0.5 to 0. That's our point there. And we'll even label that. And we have 2, 0. So our other endpoint is at 2, 0. So our domain is -5 or -1/2 to 2, but not including 1. You can see how there's this asymptote at 1. So we can't actually input 1. And then our outputs, we get out 0, and we get out every positive number, and we get out every negative number. And so our reasoning was valid. We got the correct domain and range. Hopefully you found this video useful. That's sort of how I think about figuring out the domain and range of compositions of functions. If you have any questions, feel free to let me know. Thanks for watching.